All right, welcome back. We're going to look today at some trig stuff that includes special right triangles. So we're going to look at two types of right triangles that show up quite a bit just in architecture and everyday life. The first one of these is a 45-45-90 triangle. That means you have two 45-degree angles as well as a 90-degree right angle. In this triangle, what we're going to try and do is list or express length of the hypotenuse, the long side, in terms of x. Well, looking at this triangle, we see we have two 45-degree angles. If we know we have two angles that are the same, that also means we have two sides of the same. It's an isosceles triangle. So if the length of this side that's already shown as x, also this length must be x. We want to find out what the length of the hypotenuse is. And we can do that using Pythagorean theorem, which we talked about earlier in the week. A squared plus b squared equals this hypotenuse of c squared. So if we set that up, that means we have this equation. We want to solve for c. What's the hypotenuse? Well, if we got 1x squared plus 1x squared, that's the same as 2x squared. We want to find c. To undo our power of 2 here, we want to take the square root. So take the square root of 2x squared. We got two things being multiplied in here. That means we have square root of 2 times square root of x squared. We know square root and power of 2 or something squared are opposite. So basically this term with the square root and the x squared cancels out, leaving x times the square root of 2. So what we can say then is anytime we have a 45-45-90 triangle, whatever the length of the legs are, the hypotenuse is always going to be square root of 2 times bigger than either of those legs. And this is just a quick way of coming up with that length. Some of you that are going on later to do trigonometry will use this a lot more. We're just going to kind of look at it now as a quick method of getting the length of the hypotenuse. Let's see how we can use that in some problems. So on this first one, they want us to find out what that missing length is. We can use this 45-45-90 pattern to do it. Now, do you have to use these patterns? No, we'll look at some other ways you can do them, but once you know them, it's kind of a nice, quick way of getting the answer. So in this one, you can see in number one, we have a 45-degree angle. Also means this is a 45-degree angle. We know it's isosceles, so if one leg's 4, the other leg's 4. We know using that pattern that the hypotenuse is always square root of 2 times as big. So if you take the length of these legs, which is 4, and multiply it by square root of 2, that's the length of x. So the answer for number one is x equals 4 square root of 2. Now, is that the only way of getting it? No. Here's another way you can do it. If this pattern stuff maybe just doesn't click with you, you can just go back and use what we did earlier. A squared plus b squared equals c squared. 4 squared plus 4 squared equals x squared. We should be able to solve and get the same answer using this. If we square 4, we get 16. 16 plus 16 gives us 32. If we take the square root of that and simplify it, should match up to the same answer. So we got to think, what are some perfect squares that go into 32? Well, 4 is a perfect square that goes into 32, but there's even a bigger one, 16. 16 is a perfect square. So 16 times 2 is 32. If you do the square root of 16, you get the same answer of 4 square root of 2. So you can see, even using Pythagorean theorem, you get the same answer. It takes a little bit longer, which is why we're going to try and encourage you guys to use these patterns, but you can get the same solution. All right, let's try another one. In the second problem, they also want us to figure out what is the value of x on this one. All right, now this one's a little bit different. They're kind of actually having us go the other way. They already tell us what the hypotenuse is. They want us to find one of the two legs, which we know should be the same. Because if we see that these two lengths of x are the same, it's isosceles, meaning these two angles have to be 45 degrees. So we know it's a 45, 45, 90 triangle. All right, so in the last problem, we multiplied by square root of 2 to get the longer hypotenuse side. On this particular problem, we're going from the longer hypotenuse side to the shorter leg side. So instead of multiplying by square root of 2, we'd want to do the opposite. X is going to be here, 5 square roots of 2. And instead of multiplying by square root of 2, we want to divide by the square root of 2. Well, if we got square root of 2 on top and square root of 2 on bottom, those should cancel out, leaving us with 5. So in this particular problem, x should be a length of 5. Okay, is it the only way? No. You could do this one. You could do this one a different way. You could use Pythagorean theorem. Again, you should get the same answer. You could go x squared plus x squared equals 5 square roots of 2 squared. X squared plus x squared is 2x squared. If you square 5 square roots of 2, anytime you're squaring something means you got 2 of them. So you got 5 square roots of 2 times another 5 square roots of 2. If you multiply this together, 5 times 5 is 25. Square root of 2 times square root of 2 is square root of 4. Square root of 4 we know is 2. So 2 times 25 is going to give us 50. If we divide by 2, that's 25 square root of 25. You get the same answer of 5. So there's different ways of doing these problems. As long as you follow Pythagorean theorem or trigonometry, you can get to the answer. All right, one more on here. Let's try number 3. So on this one, this is one kind of similar to the one we just did. A little bit different though. You got, again, the longer side, so we're going to a shorter side. You got to think, do we want to multiply by square root of 2 or divide by square root of 2? Because that's what the pattern says. There's a difference of square root of 2 between the legs and the hypotenuse. Well, we know this leg of 12 is, or this hypotenuse of 12 is longer than the legs. So if it's longer, we don't want to multiply by square root of 2. That gives us something bigger. We want to divide by square root of 2. So if we take 12 and divide by square root of 2, that's going to be the length of these legs. So on this particular problem, x is going to equal 12 divided by square root of 2. Now in math, it's not very appropriate to leave square roots in denominators. So how do we leave this answer so we don't have square root on the bottom anymore? What you can do is if you just multiply by the same square root, you can get rid of it in the denominator. So we're going to times the bottom by square root of 2. But that also means if we multiply the bottom by square root of 2, we have to do it to the top as well. So if we simplify this now, we will no longer have square root in the denominator. On top, we have 12 square roots of 2. On bottom, square root of 2 times square root of 2 is the same as square root of 4, which equals 2. We can simplify even a little bit farther here. If we divide 12 by 2, we end up getting 6 square roots of 2. So that would be the length of both of these legs. That's the pattern of 45, 45, 90. The other triangle that often shows up in a lot of geometry, architecture, that type of stuff is a 30, 60, 90 triangle, meaning you have a 30-degree angle, 60-degree angle, 90-degree angle. In this particular problem, we're going to look at this equilateral triangle, and we're going to try to figure out what the height is in terms of x. If you look, one of the sides is 2x, which also means this side would have to be 2x if it's equilateral triangle, and this whole bottom length is also 2x. However, if we're drawing in the height, which would go right down the middle, that would split this bottom length in half, meaning that's x and that's x, because x plus x would equal 2x. What we want to figure out is what's this height here. Well, again, we could use Pythagorean theorem to do it since we have a right triangle here with our 30, 60, 90 triangle. So let's set up Pythagorean theorem for this one. On this one, our long side is the 2x. Our a and b are the two legs. So we got a squared plus x squared equals 2x squared. If we can solve that for a, we will know the height. Well, we got a squared plus x squared. If we square 2x, again, meaning squaring means you have two of them, 2x times 2x. That would be 4x squared. Let's combine these like terms here. Let's subtract an x squared from both sides. If we do that, now we got a squared equals 4x squared minus 1x squared is 3x squared. We want to know what's the height, or just a here, so take the square root of 3x squared. Meaning we have square root of 3 times square root of x squared, and like we talked about before, square root of x squared would just be x. So we got square root of 3 times x. So just kind of summarizing this then, if you have a 30, 60, 90-degree triangle, if we call the short leg x, that means the hypotenuse is twice as long. And the longer leg is, as we can see down here, whatever the short leg is times square root of 3. This pattern will always work for any 30, 60, 90 triangle. Let's try it on a problem here. So on number 4, they want us to find two missing sides. So what's the value of x and what's the value of y? Well, using our 30, 60, 90 pattern, the short side is always going to be half as much as the hypotenuse. You can see if the shorter leg is x, the hypotenuse is twice as long. So if our hypotenuse is 10 here, that means this shorter leg should be half as much. So if we divide by 2, we can see what x is. So if you take 10 divided by 2, you get 5. So that means this length is 5. Our longer leg is always whatever our shorter one is times square root of 3. So y over here should be whatever our short leg is, 5 times the square root of 3. So you can see you can get the answers very quickly if you know the patterns and can apply them. Now, again, is this the only way to do it? No. We could use SOHCAHTOA, Pythagorean theorem to get the same thing. Let's just show you that it works. Let's find that x we got of 5 using SOHCAHTOA. If we're using our 60-degree angle here, we got the opposite side, adjacent side, and hypotenuse. We could find x using adjacent and hypotenuse or cosine. So if we do cosine 60, that should equal the adjacent side x over the hypotenuse of 10. If we solve this, it should give us our same answer of 5. Put it over 1. If we cross multiply, that gives us 10 times cosine 60. Going on our calculator, we should be able to calculate that out. Remember to make sure that you are in degrees when you do this. So if we type in 10 times cosine of 60, we get the same answer of 5. So there's other ways of getting these answers other than the patterns, but you can see the patterns make it a lot quicker. If we want to find y now, we could do the same thing, use Pythagorean theorem, and we should come up with the same answer of 5 squared root of 3. Okay, one other thing we're going to be talking about along with special right triangles in this lesson is something called angle of elevation and angle of depression. This is on the other side of your note sheet. Angle of elevation, if something's elevated, it's higher up than where you are at. So on this one, we got this little observer down here, this little person looking up at this hot air balloon. The sight line is listed right here. The sight line, along with the elevation of the hot air balloon, forms a right triangle. And the angle of elevation would be this angle that the person is looking up at to see the hot air balloon. So elevation means angle looking up. There's also something called angle of depression over here, which is the angle looking down. So I want you to draw these two pictures out, and we'll take a look at this more tomorrow.